Hello everybody, it's time for another screencast for science. In this screencast we will be discussing air masses and fronts. An air mass is a large body of air with similar temperature, humidity, and air pressure. They will form over large land and water masses. Whether an air mass is warm or cold depends on the temperature over which the mass forms. Four types of air masses. There's tropical, warm air masses that form over the tropics. There's polar, cold air masses that form over the poles. Maritime, which are air masses that form over the ocean. They are very humid. And continental, they form over land and are usually dry. Continental means land, and this air mass forms over large areas of land. Think continents. Maritime means water, and these form over large masses of water. Think oceans. Polar forms over the poles where it is cold, like this air mass. Tropical forms over the tropics, near the equator, where it is warm year-round. This picture shows the major air masses and their sources in North America. Weather fronts are where air masses meet, but they do not mix due to the different temperatures and densities. Remember that temperature changes the density. There are four kinds of fronts: cold, warm, occluded, and stationary. Yes, you do need to know the symbols for each. Cold fronts are where cold air is pushing in to replace the warm air, and the air gets drier in a cold front as it moves through. Remember, a cold front replaces warmer air as the cold front is denser than the warm front. Also, pay attention to the picture above. A blue line with triangles pointing in the direction of the movement represents a cold front. Notice the clouds in front of a cold front. So a cold front is rapidly moving cold air masses that runs into a slowly moving warm air mass. The denser cold air slides under the lighter warm air and pushes it up. The rising air cools and condenses, forming clouds. These clouds can lead to heavy rain or snow. If there isn't enough moisture, it will only be a cloudy day. Cold fronts move quickly and can cause abrupt weather changes, including violent thunderstorms. After the cold front passes, though, cool, dry air moves in and clear skies with lower temperatures usually follow. A warm front is the zone where warm air is replacing colder air. Air gets more humid after a warm front moves through. Warm air masses collide with moving cooler air. As you can see, the half circle pointing in the direction of movement. Also notice the warm air moving over the colder, more dense air. As moving air collides with a slow-moving colder air mass, the warm air moves over the denser cold air. If the warm air is humid, it showers light rainfall along the front where the two meet. If the warm air is dry, it can create scattered clouds. Because warm fronts move more slowly than cold fronts, the weather may be rainy or foggy for several days. After the warm fronts passes, the weather is likely to be warm and humid. In winter, warm fronts bring snow. Cold fronts move faster than warm fronts. The weather activity in a cold front is often violent and happens directly at the front. Cold fronts have sudden gusty winds high in the air, creating turbulence. The weather activity in a warm front generally happens before the front passes. In a warm front, the cloud formation is very low, often creating situations of poor visibility. Third kind we will discuss is an occluded front. It's formed when a cold front overtakes a warm front. This usually results in storms. But a warm front is trapped by two cold fronts, shown on the weather map by a purple line, with alternating triangles and semicircles pointing in the direction the front is moving. Picture on the bottom is a good representation of why storms occur. As the warm air is forced up, then it cools, dropping its moisture as it condenses, which is why we usually see strong storms along these fronts. Occluded front is when a warm air mass is caught between two cooler air masses. The denser cool air masses move underneath the less dense warm air and push it upward. The temperature near the ground also becomes cooler. Warm air mass is cut off or occluded from the ground. As the warm air cools and its water vapors condense, the weather may turn cloudy or rainy or even snowy. Fourth type is called a stationary front. This is when a cold or warm front stops moving. It is represented by triangles pointing toward the warm air and semicircles pointing toward the cold air. When the front starts moving again, it returns to either a warm or a cold front. A front stops moving or is moving very slowly in a stationary front. Below are pictures showing you the correct representation on a weather map and another picture depicting the cold and warm fronts. Sometimes a cold and warm air mass meet, but neither has enough force to move the other. This is where they are in a standoff or stationary, not moving. Where these two fronts meet, the water vapor in the air condenses into precipitation. It may stall over an area, bringing many days of precipitation or cloud cover. In this picture, there are all four fronts we discussed. The hardest one to find will be the occluded front in this picture. Hit pause and see if you can find it. Circled are the cold fronts. Here is the warm front, the stationary front, and finally, up top, half hidden, is the occluded front. Remember, it's purple. So now that you are getting an understanding of how these work, let's create a scenario. You are planning to travel to Alabama, represented with the star in 2 days. The high temperature for you today is 68 degrees. What do you think the temperature will be in 2 days? Will it rain? There's a cold front approaching. The temperature will probably drop. In this case, it is not running into a warm front, so it probably will not rain. The weather is more complicated than what we discussed, and meteorologists use more data to predict weather. This is why it's just a percentage, as they just look at all the data and come up with the percentage it will rain, snow, etc. Temperature is much more accurate to predict. I think this picture explains weather in South Georgia pretty well. That's it for now. Thanks for watching.